It is true that microwaves are commonly used in our everyday lives, whether it be for heating up food or for helping our wireless phones work. But what exactly are microwaves? A microwave is actually a type of electromagnetic radiation, which is a form of energy. Electromagnetic radiation can be transmitted in the form of a wave or as a particle, but a microwave specifically generally takes the form of a wave and is expressed as a wavelength. Microwaves can also be seen as part of the electromagnetic spectrum, which pictures different types of electromagnetic radiations and their wavelengths and frequencies. On the spectrum, microwaves can usually be found between radio waves and infrared light. They have a frequency between 1 GHz and a wavelength between 1 millimeter and 1 meter. Microwaves can also be grouped into specific bands depending on their wavelength. C-band microwaves are of median length, referring to their wavelength. These specific bands can be used for weather forecasts, such as tracking hurricanes or to study our planet from above. This is because they are able to travel through harsh environments, such as heavy clouds and rain. One common use of microwaves is to transmit information. This helps wireless phones and satellites work. Communication satellites are able to send signals to ground stations using C, K, and Ku bands. Microwaves work so well they are able to travel through both the atmosphere and the ionosphere, which is a part of Earth's atmosphere that is made up of many ions and free electrons. They are also able to transmit over incredibly large distances, as long as there's nothing standing in its path that will reflect or absorb the beam. Since microwaves commonly take the form of a wave, their travel can be affected by many factors. One factor is interference. This is when two waves superimpose each other and the amplitude of the wave may get smaller or larger. Or reflection. This is when the wave hits a surface and changes direction. Refraction will bend the wave if it hits a material that has a change in speed. And finally, diffraction. Diffraction will occur if the wave encounters an obstacle, such as a tree or a house. The wave will spread out in an attempt to get past. These properties are the reason that transmitters and receivers must be in line of sight with each other. An important and helpful property of microwaves is that they are unable to pass through metals. Instead, when a microwave hits a metal surface, it is reflected. Without this property, our wireless phones wouldn't work. A signal, microwave radiation, is sent from a phone and then reflects off walls and metals until it reaches a transmitter mast. This group of transmitter masts then sends the signals to the receiving phone. In terms of communication, some people have been worried that microwaves may be damaging to health. Mobile phones are only able to emit up to 2 watts per kilogram of radiation. This is the specific absorption rate. This radiation will at times be absorbed by our bodies. When this happens, the energy from the microwave can cause the temperature of our cells to raise at most 0.5 degrees Celsius. But overall, scientists seem to agree that microwaves are not particularly harmful. The fact that microwaves are able to create heat has been beneficial in many areas, such as cooking. An object will begin to heat up once the microwave radiation is able to make its atoms and molecules vibrate. The exact temperature depends on the intensity of the radiation and the length of time the object has been exposed to it. If a microwave has a very specific wavelength, it will be absorbed by water molecules. In microwave ovens, there rests a small device known as a magnetron. Once the oven is connected to an outlet, the magnetron will use electrical energy to relay the microwaves into the oven through a number of electrons. Microwaves have also played a huge part in furthering scientific research. A little over 50 years ago, scientists were able to use microwaves as support of the Big Bang Theory, the beginning of the universe. The scientists were experimenting with microwaves and heard a sound coming in all directions. After more extensive studies, they were able to prove that our universe contains an infinite amount of cosmic microwave radiation. Another branch of science that was helped was the study of moving objects, such as airplanes and spaceships. Studies increased as the radar system was used. In the radar system, microwaves will be released. The microwave then travels to the object being observed, a spacecraft, for example, and it is reflected back to the radar system. The radar system will be able to calculate the speed and gather other information on the object. Overall, it is quite amazing the extent and range that microwaves have helped humankind, from heating up a meal to unbelievable scientific studies. As microwaves are researched further, hopefully there are even more uses waiting to be discovered.